Welcome back. So today we're continuing in 3.1 and continuing our conversation on scatter plots and correlation. Now we're going to talk about how to measure linear association, okay? So the correlation coefficient R measures the strength of the linear relationship between two quantitative variables. Now again, I'm hoping most of this is review for you, whether you had AP Stats or your Algebra 2 class covered it. Most of this should be review to you. That would be my hope. So R is always between -1 and 1. If it's greater than 1, it's a positive association. If R is less than 1, it is a negative association. If it's close to 0, that means that there is almost no association. And the strength increases as it moves towards 1 or -1, okay? Either becoming more negative or more positive. That is strengthening the relationship. And of course, if it actually is either 1 or -1, it is a perfect linear relationship, okay? So basically, this R value is going to be a quantitative measure of that strength, okay? So just rule of thumb as you're working with this, this is kind of a general outline of how to describe it. If you have a correlation between 0.7 to 1, you're talking about a pretty strong relationship there. Between 0.5 and 0.7 is moderate. Once you get less than 0.5, now you're diving on the weak side of things, okay? Now, just to give you kind of an idea of what we're talking about, these are some examples of correlation, okay? So notice this first one right here. There is no relationship. You're not seeing any discernible pattern, so it has an R of 0. Here, you're seeing a slight negative pattern beginning to form, okay? And here you see that negative pattern strengthening. So notice that R is getting more negative until it reaches almost -1, where it is almost a near perfect negative sloped line. These ones, obviously, you're seeing a slight formation of a positive relationship, and then here a strengthening positive relationship. So here again, we're talking about R measuring that linear relationship, the strength of that linear correlation. So let's talk about some facts, okay? Because there is a formula to calculate R, but it's not something you're ever going to need to use, okay? You're always either going to be given the information to plug in the calculator, or it's going to be in a Minitab output for you, which I will show you. So, some facts. Correlation makes no distinction between explanatory and response variables. What does that mean? Well, what that means is here, I'm using GPA to predict ACT score. Over here, I'm doing the reverse. I'm using the ACT score to predict someone's GPA. But notice, either way, it has the same correlation. So I could flip my axes. I could flip those two the explanatory and response variables, and the correlation doesn't change. That strength of the line is still going to be exactly the same no matter which way I'm looking at it. Correlation does not change if you change the units of measurement. Okay, so here, notice I'm measuring height in feet. Here I'm measuring the height in inches, okay? But notice that strength, once again, is exactly the same. That measurement, the way that I measure it, is not impacting the relationship, okay? It's just changing the units with it, but the relationship is still just as strong. Correlation itself has absolutely no units of measurement, okay? And it requires both to be quantitative. I think that's a pretty natural one. I don't think anybody gets really confused by that rule. Obviously, you can't measure a relationship if you're not dealing with quantitative, with measurable things, right? All right, so correlation does not describe curved relationships, no matter how strong it may be. So here you are seeing a perfect parabola. But notice that R is 0, okay? R is 0 because R can only measure linear things, okay? Can only measure linear relationships. Correlation is not resistant. R is strongly affected by outliers. So notice right here, this is a near perfect line. This one point, and look at how far it drags R down, okay? So that's another thing that you need to know. It is very affected by those outliers. And then finally, it is not a complete summary of two variable data. To interpret a scatter plot or association, you always need to give a complete FODS. You also must see the scatter plot to give a complete interpretation. Let me show you why, okay? So let's say you were told a set of data had an R value of 0.9. How would you describe the strength of that relationship? Well, an R value of 0.9, you say, hey, that's a pretty strong linear positive association. Okay, but when you're only looking at that value and you're not seeing the scatter plot with it, you could misperceive the information. So here, what if I showed you that? That is actually the data that gives you that R value of 0.9. Would you still say that that is linear? My hope is that you wouldn't, okay? That's not a linear representation of data. It is very curved. So remember, R is not complete, okay? You should not be describing data just based on an R value. You have to see the data in a scatter plot to be appropriate, okay? It can have a high R value without actually being linear, okay? Which sounds a little bit weird, but it is possible, as I just showed you. I do recommend you sketch this graph down because that is something that can confuse some kids when it shows up on the AP test. All right, so let's dive into, for each one, choose the best estimate for R and interpret the association or correlation in context. So obviously, you're never going to have to just look at something and give me an R value, but I want you to know what would be appropriate, and then in the next section, we'll start diving into calculating it using the calculator, okay? So first off, I think you can rule out the negative ones right away. You can definitely see that this is a positive relationship. You can see that it's definitely on the stronger side, okay? You can see a distinct linear pattern happening here. So I'd say the R value 0.85 would probably be the most appropriate, okay? And then interpret the association in context. Interpreting association is going to be FODS. Okay, whenever you're describing or interpreting association, we're talking about FODS. Okay, so here, there is a strong positive linear association between boats registered in Florida and manatees killed by those boats. Okay, note every piece of FODS is noted in there. So whenever it asks you to interpret or describe, this is what you should be doing for me, okay? Writing that nice complete sentence that I showed you yesterday. And this one. So here, I think this is a little bit harder. Now, I think we can definitely see that there is a relationship and that is slightly positive, but it's definitely not as formed this time, okay? So I'd say probably the best of those would be the 0.4. You can see some positiveness happening, but again, it's not really too well formed. All right, now, how would I describe it? Oh, maybe I should move it. How would I describe it using FODS? Well, there's a weak linear association between storms predicted and storms observed. There's a possible outlier at 1527 for has a high number of storms observed for the number of storms predicted. Okay, so for the number of storms predicted, it should have a lower value. So remember, whenever you notice an outlier, remember you should always be telling me why is it an outlier? What's unique about it? Well, what's unique This point right here should be lower. It should be closer to right here or something like that, okay? It should not be that high. So let's think about, well, what if that point were removed? What if the outlier were gone? Well, remember we had the conversation. Outliers drastically decrease your R value, okay? Brings it closer to 0. So here, if we removed that outlier, R would increase. Okay, whenever you remove an outlier, your correlation goes up. Okay, well, actually, I should be technical, gets closer to either 1 or -1, whether it's negative or positive, okay, to be technically precise. In this case, since it's a positive correlation, it would increase. It would strengthen the relationship to remove the outlier. All right, so that is going to be it again for our notes. So again, thank you for joining me for this, and please let me know if you have any questions about these notes.